Good morning, children. Today, let us start a new chapter called Arithmetic of Integers, chapter 3. Okay, Arithmetic of Integers. In this chapter, we shall learn well ordering property of natural number, method of induction, method of mathematical induction. That is in the first exercise, that is 3.1. We shall learn all this well ordering property, method of induction, method of mathematical induction. We all know n, n is what? N is a set of natural number. N is called set of natural number. We can write it as 1, 2, 3, 4, to infinity it is. Okay? Set of natural number. W is what? Set of whole numbers. 0, 1, 2, 3, to infinity. Okay. W is called set of whole numbers. Z. Z is what? Z is set of integers. We can take here 0 plus minus 1 plus minus 2. Okay. So all the negative numbers and positive numbers plus 0 forms the set of integers. Q. Q. Q means set of uh, rational number, a number that can be expressed in the form p by q, where p, q are integers, p, q belongs to integer, and q not equals to 0. Okay, the set of rational numbers. Then R represents set of real numbers. Okay, x is a real number, real number, and C denotes set of complex number, x plus iy. Okay, that xy are real numbers, x and y are real numbers, and I equals square root of minus 1. So these you should know. What is natural number, what is whole number, what is integer, what is rational number, what is real number, what is complex number. But in this chapter, we shall mainly stick to natural number. We should remain stick to natural number. Now, we know that in between two consecutive natural number, 1 is less than 2, 2 is less than 3, 3 is less than 4. Okay, and it will go on till infinity, it will go on. So this property of ordering of natural number between two consecutive natural number, one is smaller than the other, another is bigger than the other. The second number here, 2 is bigger than 1 and 1 is smaller than 2. 2 is smaller than 3, 3 is bigger than 2. So this phenomenon is called order ordering property. In a natural number, the set of natural number is well ordered set. Is a we can say is a well ordered well ordered set. Okay. Now comes set of now comes the method of induction. Now well ordered set of is a well ordered set. We shortly write W O P. That means well ordered property. This is called well ordered property. That means since in a natural number, one is first number is smaller than the second, second is smaller than third is smaller than fourth, and so on. This is called well ordering property of natural number. So we say that natural number is a well ordered set. Next comes method of induction. Okay, if one belongs to natural number and k also belongs to natural number, say k is another natural number, then k plus 1 also will be a natural number. It will also belongs to natural number. See, if I know what is k, I can find the next number. Okay. So if I know the next number is say k dash or k1. K1 belongs to natural number. I can find k dash plus 1. This also will belongs to natural number. This way, we can find the whole set of natural number. Okay? We can find the whole set of natural number. So this method of finding the set of natural number is called method of induction. If we proceed this repeatedly, if we proceed repeatedly this way, if we proceed repeatedly, we shall get the whole set of natural number. Next comes method of mathematical induction. Third one, method of mathematical induction. Say Sn is a statement. Sn is a statement. Is a statement, mathematical statement. Mathematical statement. Mathematical statements, what do you mean? Any statement you can say. Say any statement you can say 1 plus 2 plus 3 3 plus 4 plus dot 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 equals, you say n into n plus 1 equal, you can say is equals n into n plus 1 divided by 2. It is a mathematical statement. Okay, so you can consider this one as 1 plus 2 plus 3 plus 4 dot dot dot. You can take it as a mathematical statement. So if S1 for natural number 1, the mathematical statement is true, is true. S1 is true for n equals 1. And if Sk k is true for n equals k, then sk plus 1 is also true, is also true for n equals k plus 1, for n equals k plus 1. Okay, so this way we can prove the whole statement. We can prove the whole statement here. We can prove left hand side equals right hand side. If we start it this way, we can prove that left hand side equals right hand side. I shall show you by taking an example after this. So this method of proving a mathematical statement is called method of mathematical is called method of method of mathematical induction. Okay, so let us take one example from exercise from exercise 3.1, question number 1. Question is using method of mathematical induction show that 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 is equals to n square is equal to n square for n belongs to natural number. That means 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 equals n square. You have to prove. Okay. So let us take let Sn equals 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 equals n square. Okay, when n equals 1, left hand side equals what? Left hand side, in the left hand side only 1 will be left here. When you take n equals 1, you will have only this 1. So left hand side will be equal to 1. Right hand side will be what? Right hand side will be equal to what? 1 square equals 1. So therefore left hand side equals right hand side. Okay, implies Sn S1 is true. S1 is true. Okay, now we shall take assume that the given statement holds for any natural number k. Okay, any natural number k, we shall prove that it holds for the next higher natural number k plus 1. So let sk is true for n equals k. Okay, therefore what we shall get? Therefore sk equals 1 plus 3 plus 5 plus dot 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 2 into k minus 1, okay, equals what you'll get? K square. Okay, that it is true. Okay, now we shall see. Therefore, s of k plus 1, I am putting in place of s, in place of k I am putting now k plus 1. What we get? We shall get 1 plus 3 plus 5 plus dot dot dot. If I put here in place of k plus 1, so what you'll get? If I put here k plus 1, so 2 into k plus 1 will be 2k plus 2 minus 1. So what you'll get? Previous number will be, it will be 2k plus 1. 2k plus 1, last number. And previous number will be 2k minus 1. If we simplify, you will get equals k plus 1 whole square. Okay, k plus whole square. Now left hand side we shall solve here. Left hand side equals what we will see. Left hand side equals what we will get. Left hand side equals, sorry, equals 1 plus 3 plus 5 plus, will get, previous number will be twice k minus 1, and the last number is twice k plus 1. Twice k plus 1. Now till this much we can put what? Till this much is what? From the previous statement we already proved this equals k square. This equal k square already proved here. See sk for we proved here. Sk 1 plus 3 plus 5 plus dot 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 2k minus 1 equal k square. So this value we shall put here. This much equals k square. And here we are getting 2k plus 1. This one I can write k plus 1 whole square. That means we are getting right hand side. We are getting right hand side. Okay. Therefore we can say as k plus 1 is true for n equals k plus 1. Okay. Hence, therefore, by the method of by the method of mathematical induction, mathematical induction, Sn holds for all n belongs to natural number. Okay, and proof. Okay, so this way we prove by mathematical induction. First what we took? First what we did? We took Sn equal the given statement. Okay, then we put n equals 1. Then left hand side, right hand side we put. That means S1 statement S1 is true for n equals 1. Then you put let Sk is a true, Sk is true, statement is true for k equals for n equals k. The statement Sn is true for n equals k. Now, if it is true for n equals k, then it will be what? Put in place of n, you put k, will get this equals k square. Therefore, you check as a statement for k plus 1. In place of n, you are putting k plus 1 and you just simplify. You check whether you get left hand side equals right hand side or not. Okay, you check left hand side equals right hand side or not. Here left hand side we started, we got the right hand side. Then the statement is true for all values of n. And this way of proving is called the method of mathematical induction. Hope you understood. You try other problems. I shall give you more done some more solved question answers. I'll give you. Whichever you will face problem, you will let me know. Thank you.